Hey everyone, it's Sarah with RegisteredNurseRN.com, and in this video I'm going to be going over our weekly NCLEX practice question. And these questions are going to be focusing on arterial blood gases, specifically those partially compensated problems versus the fully compensated. And if you would like more practice on how to solve ABG problems, you can access the free quiz at the end of this video. So let's get started. Our first problem says, a patient has the following arterial blood gas results: a blood pH of 7.43, a PaCO2 of 28, and a bicarb, which is an HCO3 of 18. This is known as A, partially compensated respiratory alkalosis, B, fully compensated metabolic acidosis, C, partially compensated respiratory acidosis, or D, fully compensated respiratory alkalosis. So when solving ABG problems, I love to use the tic-tac-toe method. This method was taught to me in nursing school, and it's worked great for those nursing lecture exams and the NCLEX exam. So if you're not familiar with the tic-tac-toe method, I highly recommend you watch my video up here in this card about how to set the problems up, and it'll help you understand how to work ABG problems with tic-tac-toe. But what we're going to do in this video is we're taking it a step further. We're going to use tic-tac-toe, but I'm going to show you how to analyze the result that you get with the tic-tac-toe method and how to determine if this is fully compensated or partially compensated, because a lot of students get confused on how to analyze that. Okay, so very first thing whenever you are solving arterial blood gases, you have to pull from your memory bank those normal values. So let's go over those real fast. Okay. We have our blood pH. What is a normal blood pH? 7.35 to 7.45. So we want it in between that range. Anything less than 7.35 is considered acidic, acidosis, or anything greater than 7.45 is basic, alkalosis. Our PaCO2, this represents our respiratory system. So any value that you see, it's talking about respiratory. So remember that, because the next value, our HCO3, which is our bicarb, this is talking about the metabolic realm. So we have respiratory realm, the metabolic. So remember that. So for PaCO2, I flip them because anything greater than 45 is considered acidic, and anything less than 35 is basic, alkalotic. So remember that. Those two values are flipped, and I wrote it this way so it would help us remember everything on this side is acid, everything on that side is basic. And then our HCO3, or bicarb, again represents metabolic, and anything less than 22 is acidic, and anything greater than 26 is alkalotic. Okay, so you remember those. Now, as you're solving the problem, there's three things you have to ask yourself in order to get the correct answer. You have to first say, is this a respiratory disorder or is this a metabolic disorder? And that's where the PaCO2 and the HCO3 come into play, because it'll help you differentiate between if it's metabolic or respiratory. Next, is this acidosis or is this alkalosis? And that's why you have to memorize these values and which side of the spectrum that they're on. Then lastly, you have to look and you have to see if this is uncompensated, meaning is the body doing nothing about it? And here in a second we'll be talking about how you can tell that. Or is it partially compensated? The body is partially trying to help, but it's still out of whack. Or is it fully compensated, meaning our blood pH has returned back to normal and it's corrected and it's compensated? So let's analyze our first problem. So again, whenever we look at this problem, it gave us a pH of 7.43, a PaCO2 of 28, and an HCO3 of 18. So what we want to do now is we want to analyze each result individually. And we're going to set up our tic-tac-toe. We have acids in this column, normal values in this column, and alkalotic basic values in this column. And we're looking for that tic-tac-toe, that 3 in a row. Okay, so what is our blood pH? It's 7.43. And a normal is 7.35 to 7.45. So this value is normal. So we're going to put pH under the normal. Okay, our PaCO2, and what did that represent again? Our respiratory system is 28. What is a normal PaCO2? 35 to 45. So this is not normal, and it's less than 35, so we know that it is basic, it's alkalotic. So we're going to put that value underneath the basic column. Next one, our bicarb, which represents our metabolic, is 18, and a normal bicarb is 22 to 26. So it's less than 22 since it's 18, so it's going to be acidotic, it's acidosis. So we're going to put HCO3 under acid. Okay, well, if you're using the tic-tac-toe method, you just put in all your values and you notice I don't have a tic-tac-toe. Well, this is where you've got to further look at your problem and know that you for sure have some compensation going on. Just got to decide, is it partially or fully? And how to do that, you ask yourself, what is your blood pH? Our blood pH is normal. So that means it's fully compensated. The body is doing its job through another system to get that blood pH to return back to normal. So we have full compensation. But next question you have to ask yourself is, well, is this a respiratory or metabolic problem? Okay, and how you do that is you look at each value and you see which one deviates the most from its normal value. So the PaCO2 is 28. What's its normal value on that low end? 35. So 35 minus 28 is 7. So it's deviating 7 points from normal. Okay. Bicarb is 18. Normal on the low end is 22. How many points is it deviating from normal? 4. So it's 4 points. Which one's the most? Our PaCO2. So we know that this is our main problem, respiratory alkalosis. Okay, so we have fully compensated respiratory alkalosis. So D is our answer. Well, so what's going on is that maybe this patient is hyperventilating. They're literally, that's where you breathe rapidly. They're blowing off all that carbon dioxide, that CO2. So it's making conditions alkalotic because an acid is going away and you have basic conditions. Well, the body likes to try to save itself. So it's going to compensate through the metabolic system, specifically the renal system, by trying to get rid of, excrete, lower that bicarb so it can make the blood pH increase back to normal since it's so basic right now. So remember, because bicarb is basic, so if the body tries to lower the amount of bicarb it has, it can hopefully flip the conditions around and make and balance itself out where that blood pH can return back to normal. So that is what a fully compensated arterial blood gas looks like. Now let's flip it over and let's see what this problem says. A patient has the following arterial blood gas results: blood pH of 7.5, a PaCO2 of 49, and a bicarb HCO3 of 30. This is known as A, fully compensated respiratory acidosis, B, partially compensated metabolic alkalosis, C, partially compensated metabolic acidosis, or D, fully compensated metabolic alkalosis. So for this problem, our pH is 7.5 and a normal pH is 7.35 to 7.45. So this is abnormal on the higher end. It's basic alkalotic, so we're going to put it under this category, base, our pH. Next value, PaCO2, which represents respiratory, is 49. Normal is 35 to 45, so it's on that higher end and it's acidotic. So we're going to put PaCO2 under acid. And then we're going to look at our bicarb, and it's 30. Normal bicarb is 22 to 26, and it's on the high end, so it's alkalotic basic, and we're going to put it over here. Okay, so we have a tic-tac-toe, which is going to tell us what disorder we're dealing with. So are we in respiratory or metabolic problem? We are under a metabolic problem, specifically metabolic alkalosis, okay? So next thing we need to determine, is this uncompensated, partially compensated or fully compensated? Well, we can go ahead and scratch off it's fully compensated. Why? Because our blood pH is not normal. It hasn't returned to normal. So we know it's not fully compensated. So now we have to ask ourselves, is this uncompensated or partially compensated? Well, we have to look at the other system that could help us correct this metabolic alkalosis, which would be our respiratory system. And our respiratory system value is abnormal, so it's trying to compensate. It's trying to throw itself into acidotic conditions to help bring down that pH back to normal. So it's trying, but it hasn't achieved its goal yet. So this is partially compensated metabolic alkalosis. Our answer is B. Now, this would be uncompensated if this PaCO2 was normal, because the body's not trying to compensate at all. So if this was over here, like this, and this value, we'll say was normal, we'll say it's 40, then the body's not really compensating. So it would be metabolic alkalosis uncompensated. Okay, so this wraps up this NCLEX practice question of the week. And don't forget to check out the other questions in this series.